Welcome to my video on the West London Replica Sundial. I purchased this new off Amazon. I forgot exactly how much it was. I think it was less than $50, maybe 30 some. What this is, it's a neat replica. It's nicely done. And this is an old sundial, and what you do is you open it up here, and this is called the gnomon. This part right here, and this is going to point north in North America, south in the southern hemisphere. And so this is your latitude adjustment. I'm at 38.2 degrees latitude, so I'm going to put it right here. There's about 38.2, and then it has a compass. So in my case, when I get it outside, I want to put the compass facing north, so my gnomon will go basically in this direction approximately. I'm going to get it outside and do it exactly. I'm just giving you a rough idea here. And these are your leveling screws. So you want to get it level when you take it outside. Your gnomon's going to point in the pole, north in North America. The compass needs to be in line with the gnomon, so you get it directly pointing true north. Well, it's going to be, actually it's going to be the magnetic north. I will show you in the video how to correct for that, for the anomaly due to the difference between the magnetic and the true north. I'm going to go over the analysis of the sundial observations I took on September 12, 2025. This is with the West London Replica Sundial, and my latitude was 38.2 north, longitude 94.3 west. You'll see in a minute why that's important. Okay, when you take the observations, you have to correct for several things, because the sundial measures the apparent solar time, but you have to correct it to make it align with the civil time. And there's four basic corrections you have to make. You have to make the equation of time correction. That's the seasonal difference due to the Earth's tilt and orbit. And you have to have the longitudinal correction. That's why I gave you the longitude just a second ago. The offset from the time zone central meridian. The time zones are based basically on the central meridian where it's at. Like I'm in the central time zone, so it's 90 degrees. And anything deviating from that will give you a slight error in the time. And then I have to correct for daylight savings time because I'm 1 hour different, because this is the summertime. And then also you have to correct for the magnetic versus the true north, because the compass alignment introduces an error, and magnetic north pole and the actual north pole of the Earth are not the same place. So you have to correct for that. So now in a video, I've got a more detailed explanation of the corrections, and I've got a link in the back. So I know I'm going to go through these corrections quickly, and if it's your first time seeing it, you may not understand it, but I've got a video that gives it more detail that will explain the corrections. So the four time corrections, the first one was the equation of time. That changed it by 5 minutes, so I had to subtract 5 minutes from what I took my solar time. I subtracted 5 minutes. Now the longitudinal correction had to do with my difference from the time zone. I told you my longitude was 94.3. The meridian for central time zone is 90 degrees west. They changed it by 17 minutes, so I had to add 17 minutes. The daylight savings time correction, since this is the summertime months, we added 60 minutes. And then the difference between the true north and the magnetic north was 2.5 degrees approximately, and that caused a subtraction of 10 minutes. So the net, if you add all these up, what I do is I'm going to take the solar time that I measured off my sundial, add 72 minutes to it, and that's going to give me the corrected clock time essentially. So this is the first observation I took for the sundial, and my clock read 10:10, and then you can see here's the shadow right here of the sundial, and I recorded that at 9. That's what I wrote down on my chart. Okay, so let's work out this first observation that I just showed you there, go through the corrections. So the clock read 10:10, and the sundial read 9. So I start with my sundial time of 9. I take off the 10 minutes for the magnetic correction. That puts me at 8:50. The equation of time correction is 8:50 minus 5 minutes. That's 8:45. Now we got the longitudinal correction here. I add 17 minutes, that's 9:02. And then I go the difference between the daylight savings time, so I add an hour, so I get 10:02. So my clock read 10:10, and my corrected sundial time was 10:02. 8-minute error, that's not bad. Any of these sundials at this caliber, you're plus or minus 10 minutes, that's pretty good. So here's my table of actual results. I took several observations during the day up until about, that was 4:05 p.m. my time. And so here's my actual sundial time that I recorded. And then here's the corrected time in this last column when I added the 72 minutes from the corrections I just went over. So this graph shows the difference between the corrected sundial time, and that's going to be this line right here, not the dotted line, but the curvy line. And then this is the clock time from around 10 to 4 p.m. And so you can see there are slight deviations. It's not an exact measurement. And this next chart, this chart shows the actual deviations from the correct time. And you can see the biggest one was nearly 12 minutes and to 5 minutes in the as a difference. So overall, actually not too bad. So conclusion, the corrected sundial readings generally track clock time within 10 minutes. So that's what you'd expect for a small little sundial like this. That is by no means bad. And then the largest errors occurred during the midday. I've seen this with other sundials, and it's just got to do with the way the construction is laid out. And the two sources of error would be like alignment, because I can't get my compass exactly lined north, and just the seasonal equation of time, probably could get that down to a better fraction of a minute. And then the location, I could probably measure that more accurately to get the exact. And then also the difference between the magnetic and the true north is slightly different also, because there could be local anomalies. So with the proper correction times, the sundial still is an instrument that will record time fairly accurately. I hope you learned a little bit about this West London time dial and how to use it and what kind of results you can expect. If you did, give me a like, thumbs up, subscribe to my channel, and thank you for watching.